Hello everyone! In this second video I want to talk about the most important property of waves, the second video for this week I should say, and that is interference. And so the thing that's really particular about waves is that they can pass through each other, and when that happens, their amplitude just adds directly. So here I have, for example, two waves. Wave 1 is in red, and then wave 2 is in blue, and they're on top of each other. So this is as a function of space. And they're on top of each other. The resulting wave, when you have two waves on top of each other, they just add up. And so you just literally, if you want to find the resulting wave, you just add these two together. So you have the red plus this one, so you get a point here. This is, I don't know, 1, and this is 1.2. The new wave would be at 2.2. You just add these amplitudes together. The wave would start like this and then go there, so it would be more intense. And so you would get what we call constructed, and it would be bigger waves because you have two waves nearly on top of each other here. But as you notice, these two waves are not always on top of each other. I chose a specific example. For example, at this point in space, the red one here may be again around 1, but the blue now is negative. Let's say -1, it's about the same. Now, at this point, the wave cancels. So while the original wave was non-zero, both waves are not zero, the resulting sum of the two waves is exactly 0. Okay? So I will not try to draw all of this wave, but I can tell you that when you have two waves which are nearly the same, then what happens is you get a pattern that looks like this. These two waves have essentially the same amplitude to start with, they just have slightly different frequency. And so what happens when you add waves like this is you get big oscillating wave, but you get big pattern, small pattern, big pattern, small pattern, big pattern. This is described as beats, and you can hear this when you tune your guitar, or I can show you here with those tuning forks. This is well described in your book, so you should have it up. And this is important. And so, if I have my two tuning forks right here, and this one here has a mass attached to it. So it's slightly different frequencies, so they're not quite the same, but otherwise identical. So I'm going to create two sound waves. The only difference is this one is a slightly different pitch, different frequency than this one. What I should hear is I should hear beats. I should hear this overall big modulation. Loud, no sound, loud, no sound, loud, no sound. Okay, so let's see what we hear. So these beats phenomena that you may have heard about in many other instances, and that you can hear here, just this slow modulation of the signal, is a phenomenon due to interference, which is by far the most important property of waves.